Like this is fine? Just gonna be silence.
Yes.
And I don't know if you know how many people watch these. It can get into the thousands. And by that I mean normally we have 2 to 3 people watching. Yes. Almost always. One is Michelle, and then usually some other.
And then the parents of whoever is being interviewed.
Yeah, and then a volunteer normally. So What volunteers watch? Don't some volunteers watch? Oh, Jackie will watch.
Oh yeah, Jackie will.
Adriana still cares about us even though she's a traitor and left. And like I said, there's no time. We just do it until we're done.
Cool.
Yes. You too. Maybe we can get up to 5 today. Wouldn't that be incredible?
I think our most was like 9.
Ooh. Which one was that on? Like, what was the topic?
I want to say that was like plants and stuff.
That was, listen, I love genetics, and the plants was interesting to me. That was one of our drier Facebook lives. There wasn't a whole lot of star-studded information in that one. Like the butterfly blocks you did last week were so cool. Or like 3 weeks ago, because Shannon decided to be gone for an extended period of time.
Like 2 weeks.
Yeah, really appreciate that. Kai, you can tell us whenever you want us to go. We can probably start. How many do we got? Do we got 2 people?
We got up to 3 and then back down.
Man, someone clicked on.
Man.
They saw me and they were like, "Nah, I don't need this. I'm over it." All right, you want to start? Okay. Well, welcome everybody to another one of our behind-the-scenes Facebook Live series here at the Butterfly House Aquarium, where we take you behind the scenes, where you can learn a little bit, see a little bit about what happens at this facility when you aren't here. Today, I'm with Shannon. Say hi to the fine folks, Shannon.
Hello.
Hello. Thank you for joining us, Shannon. I appreciate it. Tell us what your job here is at the Butterfly House Aquarium.
So I am one of the aquarists here. My job is basically taking care of all of the aquatic things. So that is, yes, the fish, all the inverts, corals, and also in our conservatory, we take care of the pond in there. So we have koi in there and turtles in there. So that's also under our responsibilities as well.
Awesome. So if it has water, it's your job.
Pretty much, yes.
Awesome.
Yeah.
What's your favorite part of your job?
The amount of different species that I get to take care of, it's fun. I love learning new things. I love learning how to take care of new animals. And also just kind of adapting the exhibits to that animal, which is also interesting. So, yeah.
Sounds like a fun challenge.
Yeah.
And this is a new question that we asked Colton last week, so I'll ask you this week.
Okay.
If you could care for any animal in the world, realistic or not, what would you want to care for?
Oh, that's a good question. I really love the cuttlefish. I just love them so much. I took care of some of them during some of my internships before this job, and then we had some here. And they're just really fun to take care of.
So you're literally living the dream.
I am,
by
yes.
being able to take care of cuttlefish.
Yeah.
Well, that's awesome. Lucky you. So, what are we going to be doing today / talking about today?
So today we're learning all about corals.
All about corals.
Yes.
What is a coral? Is it a mineral? Is it a rock? An animal? A plant? What is it?
It is an animal that has plant-like characteristics. So, as you see here, all of the different colored things that we have in here are corals. They do have tissue, and within that tissue, they have algae, which is the plant-like portion of them. So they have symbiotic algae that basically helps create food for them. So they use photosynthesis to create the sugar that then the algae does use some of that, and then the coral uses most of it. And then on the other side of the relationship, the coral helps protect the algae from anything, really. So it's a mutualistic relationship.
Interesting.
Yes.
And so I know we have a coral skeleton here.
Yes.
You want to talk a little bit about this skeleton?
Yes.
Come on in, Kai. Let's get a nice up close view in this wonderful lighting.
So the corals, so each coral is essentially a colony of polyps. So within all of these little circles are called corallites, and that's where the polyp will sit. So the polyp is the individual animal, and then obviously as it grows and reproduces, the polyp excretes calcium carbonate, which is what the skeleton is made out of. So as it grows, obviously it gets bigger and bigger, and depending on the environment that the coral is in, it will grow differently. So flow, whatever. Some are branching, some are encrusting, some are bouldering corals, so they just kind of look like little rocks. So yeah.
Wow, so they grow their own rocks, essentially.
Essentially, yes. They grow their own skeleton.
That's pretty awesome. Well, yeah, they grow their own skeleton, but it's like a rocky skeleton.
Yep.
That's neat. I wish I could. I mean, I grew up my own skeleton too, but mine's all inside, so it's a little more boring.
Yeah.
So they're animals.
Yes.
What do they eat? Because when I look at this, I'm like, okay, sure, they're an animal. Maybe, I guess, if that's what you're telling me, I'm going to believe you. But they kind of just sit there. They just look like rocks.
Yeah.
So what do they eat? What do they do?
So, obviously, a part of them is the photosynthetic algae that is within them. So the lighting over the exhibit is very important. We use what we call PAR. So PAR stands for photosynthetic active radiation. And essentially, each coral needs to be at a certain PAR for them to thrive. And so we have a sensor that we use to measure. So in our exhibit, we add ocean snow, which is just kind of like a bunch of different types of really, really tiny organisms and nutrients. And then we also add what's called reef chili. And that is also a mixture of tiny copepods or just like really microscopic organisms that they would otherwise eat. So we also sometimes feed them calanus, which we have to blend up to make sure that the polyps are able to consume them. So within each polyp, there is a mouth. So they use their tentacles to bring in their food. So
Interesting.
yeah.
So, and whenever I think about corals, I think of them, and this might be completely wrong, and you can tell me if this is completely wrong. I think of them almost as like little tiny mini anemones that can't really move and just live together and live in a colony. Is that completely just, am I making that up in my head?
No, you're not.
In terms of like how they look, like if you took an anemone with all their crazy arms and you shrunk them down, you kind of have a coral.
Kind of, yes.
Kind of?
Yeah.
Okay, I'm glad I was right. I just kind of wanted to feel better about myself. Where in the world can you find coral?
So coral reefs. So 90% of coral reefs are found in the Indo-Pacific region. So basically, where this exhibit, or the animals that are in this exhibit are from. Coral reefs are really important just structurally. They help for protection, either from the shore or from animals will hide within the coral reefs, obviously for protection from predators. And so there's a lot of different types of ecosystems that can happen within a coral reef. So they are very important.
And they are in a lot of places in the world.
Yes.
Yeah, they're...
Yeah.
Well, so whenever I have kids at this tank especially, they're always like, wow, there's so many colors. Why are they colorful, one? And two, why are there so many different colors?
So their color mainly comes from genetics. It's just what the genes that the coral has. Part of it is from the algae. The algae that is within them is a blue-green algae. But they do have pigments that they produce, protein pigments that they produce to create the coral or create the color that they are. And it also depends on the lighting that they have. So some corals can create a sunscreen, essentially. The pigments do help them from the harmful UV rays, so that all they get is the nutrients that they need from the sun. So there was a while ago, there was one time where we had a mishap with one of our lights, and it was on all night. And one of the corals actually changed color because of the constant light that it was getting. It created more pigment to help protect itself, and essentially creating a sunscreen so that it wouldn't be harmed from the constant light.
That's very interesting.
Yeah. So
there is a reason behind the color. It's not
yes.
Just, not just cause.
It's not just cause. No. Yeah. There's a function behind the color.
Very interesting. Why don't we walk over to our soft corals?
Okay.
Because I have a question about soft corals.
Okay.
So when we're talking about all the coral in the Pacific Coral Reef, and they're all hard corals. So they all have that skeleton that they built. That
stony,
yeah. What's different about the soft coral?
The soft coral, essentially, well, I'm still in the process of learning about these guys, but they basically have, especially on all these corals, all the things sticking up are their tentacles, I believe. So this is, as far as I know, one giant polyp instead of having the colony. And then these guys are just little colonies of different polyps. But they just grow their...
Okay, we're back. Sorry for the technical delays. Technical difficulties, I should say. You can blame Kai. He's our cameraman. We did something wrong. But we're back. So essentially, the difference between soft and hard corals...
It's just that they have a harder skeleton.
The hard coral grows that hard skeleton.
Yep.
The soft coral doesn't grow a hard skeleton.
So you will definitely find these in different areas of the reef because they don't have a hard skeleton. They don't have that structure, and so flow has a much greater effect on them than it would. So these would be kind of more in the little crevices.
They're not hardy enough to be just out in the open water.
Yes. Yeah.
Oh, cool. What goes in? You talked about this a little bit already, but what goes into caring for coral in a captive environment? And what kind of special things do coral need that nothing else needs? That you have to do specifically just because they're coral?
So corals are very, very sensitive to everything. So the parameters that you need to keep track of while taking care of coral is light. So as I was talking about before, is the PAR. Each coral needs a certain level of PAR. The flow. Each coral needs a certain amount of flow. Some corals love really high flow, and it actually helps them, like their polyps come out and their structure. Others love really low flow. The other part of it is water chemistry. So what we test for our coral tanks outside of all of our other systems, so all of our other systems we test ammonia, nitrites, and nitrates, so the bacterial cycle. We test alkalinity, and we test pH and phosphates. For corals, we also add on calcium and magnesium. So that's what they pull out of the water to grow their skeleton. It is very important. And the calcium, magnesium, and alkalinity are all pretty much tied together. So if one crashes, the others are affected. So there's a very precarious balance that we have to maintain within these tanks. And also if we do maintenance on these tanks, we have to keep in mind if it affects the water chemistry at all. And we have to kind of work around that, I guess. So.
Interesting.
Yeah.
So one more question before we go back. Sometimes I will come in here after a long week of working. I'm just like, oh, I can't wait to look at my favorite coral, and it's moving.
Yes.
I know that coral can't really move, unless something else moves. So, what happened?
So we move our corals both within the exhibit, either, so currently we're in the process of re-aquascaping our Indo-Pacific exhibit, and that has to be done very slowly. And so corals do move within the exhibit, and then corals, we also move corals onto, we have backup systems in our backup area. So either we can frag corals, so what fragging mean is basically breaking off a piece of a coral. And when we do that, it doesn't kill the coral at all. We glue it to a little plug, and then it can grow a whole new colony. So we can do that if we want to, have a certain species of coral in a different tank. We can just kind of frag one and then grow it in the other. Also, if a coral is having issues, so if we notice that it started bleaching, it may be diseased or anything like that, we may move it to a backup area so we can get a closer look at it, keep a better eye on it, or if it needs medication, medicate it if we need to.
Interesting. I know I said one more question, but I have one more question. You made me think of something. Are there diseases that corals can pass to each other within the tank?
I don't know that question. There is stony coral disease that is happening in the wild that scientists are currently trying to figure out what the cause of it is, and if there's anything that we can do to help alleviate it. And it's one of those diseases that's happening and it's kind of wiping out a lot of populations of corals. And so we're just trying to get on that. So that is one I do know that is pretty important that we're trying to figure out. There's another one that we kind of had in our Indo-Pacific tank recently. It's where usually we know coral bleaching is what we've seen. Pictures everywhere. Climate change, yes. So that one is usually, once a coral bleaches, that's a pretty good sign that something is wrong. What was happening in our Indo-Pacific tank was that they weren't bleaching, but the tissue was separating from the skeleton, but this tissue still had all of its color. So it still had all its algae in it. And so we think that there was a bacteria that was eating at the coral, and so we gave them witch hazel dips. So we take the corals out of the tank and dip them in buckets of certain solution of witch hazel for a certain amount of time, and then we put them back, and that seems to have really helped them. So basically, the witch hazel killed the bacteria that was causing that damage. So I don't know the exact name of what was happening, but
there are diseases, but it's not nearly as clear as maybe diseases that would be passed between mammals or fish. Maybe it's a lot. It's still being researched.
yes.
Interesting.
Yeah.
Well, you want to go look at the coral hospital a little bit?
Sure.
Let's do it. It's going to be loud and cramped. That's okay. Hands up. Thank God.
Just giving them better environment.
Yeah. And I see, the little things, little circles, those are called
plugs. So plugs can be made of many different materials. These plugs are made of a material that kind of helps bacteria get into it and live in it. But there are also plugs that are just plastic. Some facilities just use, PVC fittings instead.
Yeah.
So it's kind of really anything that you can glue a piece of coral to that will help.
There are some that are a little better than others, but in the end, a plug's a plug, basically.
Yep.
Huh. Yep. Interesting. And then so they'll go from the plugs, you grow them on the plugs, and hopefully you'll be able to transplant them at some point in time into an exhibit. And you'll just take the plug and flop it in, basically?
Basically glue the plug to the live rock that we have in there.
And then the live rock will grow around it, correct?
The coral will grow around it. Yes.
The coral, yes. Not the live rock. Coral's not rock, I'm aware. Something that I've just noticed about this tank that I haven't noticed before, well, there's a lot of colors that aren't on a plug. Is that just algae growing? Like all this red, for example? What is that?
So a lot of it's algae. We recently had a crash in this system. So all of these used to be live coral. It was basically coral from frags that were on the racks. They spawned, and then they just kind of attached to the sides of the tank.
Huh.
So,
Okay.
yeah.
All right, I got one final question for you.
Okay.
We're here in South Dakota.
Yes.
Thousands of miles from any coral reef. Where do we get coral from? And do we get new coral very often, or do we kind of just use what we have? Or
It kind of depends on the space that we have and what our goals are for the exhibits. So obviously we want to make sure we have the space and the right environment for the corals before we get them.
Yeah.
So make sure that happens, and then we get our corals from various distributors that collect them from the wild or grow them within their own facilities. We also get corals from other facilities as well, that either their corals growing too big, and so they frag it themselves, and then they have a surplus of whatever acropora frags or something, and so facilities will also do that as well.
Neat.
Yeah.
Of course, I said final question. I actually have one more follow-up question.
Okay.
How big are corals when we get them shipped to us? Are they essentially like this size, like just on one plug?
It depends, but obviously you don't want to ship a giant piece of a coral because that's more money. Yeah. And more weight, more water weight. Water is very heavy. So yeah, essentially they will probably be like 1 to 2 inches in size.
Neat.
Yeah.
Well, is there anything else you think people should know about coral? Anything at all? Any fun facts you want to share?
Yes. So corals have a mucus lining around them. And what I've learned recently, and you could probably go on YouTube and watch videos of this, if any debris or even food falls on them, they're able to move it either to their mouth to eat it if it is food, or to move it off of them if it is debris. So they'll kind of like work together, the polyps, to kind of help each other in that sense. It's really interesting. It doesn't happen very quickly. Obviously all the videos will be time lapse, but it does happen. So they are able to kind of push things off of themselves.
Wow. Colonial animals are fascinating, especially ones that live in the water. That's even cooler.
Yeah.
So, Shannon, I appreciate you taking time out of your very, very, very busy aquarium schedule to talk to us a little bit about coral. For anyone out there listening, there is so much more to know about coral. Coral is a topic that I think you could probably study for years and years and years and never come even close to being a 100% expert on. So, thank you, Shannon, for sharing your expertise, which is leagues beyond mine. And thank you, Mom, and all other viewers for tuning in and watching. We appreciate, as always, as I'm stuck here praying in the corner. Make sure you join us next time for another behind-the-scenes tour of some sort. What are we going to be doing? I don't know. I'll figure it out after this probably, but we'll let you know. And hopefully you'll tune in and join us to learn some cool stuff. So join us next time. Bye!